In example 5 here, we have, once again, scores on an exam, which are normally distributed. The mean is 70 and the variance is 16. First thing to notice here is that you have to be careful. It says the variance is 16, not the standard deviation. So that means our sigma is actually the square root of the variance, which will be 4 here. That mean will be 70. We want to figure out what percentage of the scores are between 68 and 78. Just like the others, the trick to dealing with these non-standard normal problems is to convert them into standard normal problems, and then you can look up the answers for standard normal probabilities on a chart. So again, I'm going to set up a standard normal, which is always y minus the mean over the standard deviation. In this case, it's y minus 70 over my standard deviation here is 4. And then the probabilities, if I want to find a probability on y, I convert that into a probability on z. That's the probability on z. And then I just plug in those values of y into the formula for z. So y minus, or sorry, I want to find y going from a to b. So that means a minus mu over sigma and b minus mu over sigma. So that's what I have to do to convert a non-standard normal variable into a standard normal variable. So in this case, for part A here, we want to find the probability that y is between 68 and 78. Let's convert that into a probability on z. Z should be between, well, my A and B are 68 and 78. So I get 68 minus, what was my mean, 70? Over my standard deviation was 4. And 78 minus 70 over 4, which is the probability that z is between 68 minus 70 is negative 2. Negative 2 over 4 is negative 0.5. And 78 minus 70 is 8 over 4 is 2. Okay. Let me draw a little graph to show how I plan to calculate that, because that'll be a little bit complicated. I'm going to need some halves somewhere. I can just feel those halves coming up. All right, I want to go from negative 0.5 to 2. So I want this area right here. And as usual, I think I'm going to split that up into 2 areas. And the left-hand area is, well, the total area would be 1/2 minus the tail area, which is the probability that z is bigger than 1/2, bigger than 0.5. I'm subtracting off a positive tail because it's symmetric. So the positive and negative tails have the same area. So this is 1/2 minus the probability that z is bigger than or equal to 0.5. And this right-hand area is, again, 1/2 minus the tail. The tail starts at, no, it starts at 2, not 2.5. So 1/2 minus the probability that z is bigger than or equal to 2. So plus 1/2 minus the probability that z is bigger than or equal to 2. I'm going to simplify that a little bit, combine the halves into 1 minus the probability that z is bigger than or equal to 0.5 minus the probability that z is bigger than or equal to 2. So I can look both of those up as soon as I get a standard normal table for myself. I'm going to hang on to those for now, and I'm going to look at part B. So part B, I want to find the minimum score to be in the top 10% of students. Maybe the top 10% of students will receive honors upon graduation. This one's a little different from the previous problem, so you're going to have to think extra hard about this one. I want the probability z being above some cutoff, and I don't know what that cutoff is yet, so I'm just going to call it little z, to be exactly 0.1, because I want it to be the top 10% of students. So I want some cutoff, and in order to be above that cutoff, you must be in the top 10%. So that's where I'm getting that 0.1 there. And I want to figure out what little z would have to be. Solve for little z, and I'll have to use that use a normal chart to figure that out. And then I want to figure out what the cutoff score is for that, because that's really going to be a z value. So then I'll get z is equal to y minus mu over sigma. Once I figure out what z is, I can solve for y. So I'll get z times sigma is equal to y minus mu, and y will be equal to z sigma, I'll write it as sigma z plus mu. So there I've solved for y. I can fill in values of sigma and mu. I know what those are right now. Sigma is 4, and my mu was 70. 4z plus 70. So what I'll do is I'll solve for z. I'll have to do that by looking at the normal chart on the next page, and then I'll figure out my cutoff value for y after I figure out what z is, and that'll be the minimum the minimum exam score to get you in the honors category. So before I go ahead and jump to the z charts on the next page, let me show you how I calculated everything here. We wanted to find the probability that y was between 68 and 78. So y is a non-standard normal variable. I converted it into a standard normal variable here, y minus mu over sigma. And my mu is given by the problem here. Sigma is, well, it says variance. That's the, the standard deviation is the square root of the variance. So the standard deviation is the square root of 16. That's why I used 4 for the standard deviation. And so if I have a range of values for y, here's how I convert it into a range of values for z. I just plug in the a and b for y into the equation for z. So I plugged those in. The a and b are 68 and 78 in this case, and I got a range for z. And then I looked at that on my chart here, on my graph, and I'm going to split that up and calculate each one of those ranges separately. Each one is 1/2 minus the tail value, because there's always 1/2 of the area on the left and 1/2 of the area on the right. So I'm really calculating 1/2 minus these two tail values. And so those are the two tail values right there that I'm going to have to look up on the normal chart on the next page. And that's how I got this answer that I'll fill in the details of on the next page. For part B, I want to calculate the minimum score to be in the top 10% of students. So I want to figure out what cutoff on the Z chart will put me in the top 10%, will give me a probability of 10% of being above that score. So I'll solve that for Z on the next page. And once I find a Z cutoff, I'll convert that back into a Y. I solve this back into Y using mu and sigma, and I'll figure out a Y cutoff. That'll give me the exam score required to put you in the top 10% of students. So let's jump forward to the next page. And here's my Z chart. And let me remind you what I calculated on the previous page. In part A, we wanted the exam scores to be between 68 and 78. And at some cost of work on the previous page, we converted that into some numbers that we can look up on the Z chart. 1 minus the probability that Z is bigger than 0.5 minus the probability that Z was bigger than 2. And I think both of those are here on the chart. 0.5 is right there, 0.3085, and 0.2 is 0.0228. So This is 1 minus 0.3085 minus 0.0228. And I reduced those and simplified those on my calculator. I just rounded it to the nearest percentage, and I got 67%, 0.67, rounded it to 67%. So that's the percentage of students that will score between 68 and 78 on this exam. In the second part of the problem there, we wanted to find the minimum passing score for above, not the minimum passing score, but the minimum score above which only 10% of students score. So the first thing was to solve for a cutoff value of z. I wanted to find a little z. Oh, that really looks like ZZZ. I find a value of little z such that the probability of being bigger than that is 0.10. That's from the 10% given in the problem. And let's see, I'm looking for a 0.10 in the chart. If I look through here, they're getting close to 0.10, really close to that number there. So that's 1.2, and 0.08 is 1.28. So that's my z value. Let me write that as my little z is 1.28. Exactly 10% of the students, or very close to 10% of the students, are above a z-score of 1.28. But now I have to convert that back into a y-score on the exam. So my y, again, I worked this out on the previous page, was 4z plus 70. So that's 4 times 1.28 plus 70. And if you calculate that out, it comes out to be very close to 75, just slightly above 75. What that means is that if you score above 75 on this exam, then you will be in the top 10% of students. If you take that y value and convert it into a z-score, you get a z-score of 1.28, which corresponds to a probability of 0.10. So let me recap here. A lot of this work was done on the previous page, converting the values for y into normal values, into standard normal values, and then we drew some pictures to figure out we could calculate the standard normal values in terms of these two cutoffs. And then on this page, we just looked up 0.3085 here and 0.0028 here. Those corresponded to 0.5 and 2.0. And then I just did the arithmetic and simplified that down to an approximate 67% of the students scoring between 68 and 78. In part B, we wanted to find what score you had to get to be in the top 10%. So this is really sort of a reverse engineering problem. So we started out with the probability of 0.10. So I had to find that in the chart, and I found it right here, very close to 1.28. So there's the 1.2, there's the 8, and that's where I got the z value of 1.28. And then, again, I worked this out. I solved that backwards with a sigma and a mu from the previous page to solve for y in terms of z. So I plugged the z value of 1.28 in, plugged in my sigma and mu, and I got a y score of 75. That means you have to score a 75 or better on this exam in order to land within the top 10% of students. If you're an honors student and you want to make sure you get those honors by being in the top 10%, you better score a 75 or better on this exam. So that's the last example, so that wraps up this lecture on the normal distribution, also known as the Gaussian distribution. This is part of the probability lecture series here on Educator.com. Next lecture is on the gamma distribution, which also includes the exponential distribution and the chi-square distribution. So if you're interested in any of those, I hope you'll stick around. My name is Will Murray. Thank you very much for watching. Bye-bye.